Autoignition is the temperature at which fuel will automatically ignite without a spark or outside ignition source. The autoignition temperature for most avgas is 840 degrees Fahrenheit or 449 degrees Celsius. Jet A autoignites at 475 degrees Fahrenheit or 246 degrees Celsius. There are a number of components on or near an aircraft that can generate temperatures high enough for autoignition to occur. It is important to ensure that fuel or fuel vapors cannot touch any surface or device that is at or near the autoignition temperature of the fuel. The residual heat present in engines and brakes can cause spilled or sprayed fuel to ignite if they have not cooled below the autoignition temperature. The visual appearance of aircraft components is seldom a good indicator of temperature. Therefore, consider all surfaces to be above the autoignition point. Even when the temperature has dropped below the autoignition level, the engines and brakes may still be hot enough to vaporize spilled fuel. All ignition sources, such as static electricity, become extremely hazardous in the presence of flammable vapors. Vehicle components, such as exhaust pipes and manifolds, are potential sources for autoignition of aviation fuels. Leaking or spilled fuel in the presence of hot engine components can ignite. Similarly, uncovered or broken lights and light fixtures create an autoignition risk. Therefore, it is important to ensure that fuel or fuel vapor cannot come into contact with any surface that is at or near the autoignition temperature of that fuel. The heat generated from the combustion of fuel is an important consideration when preparing to fight a fire. Heat is measured in British thermal units, or BTUs, where 1 BTU is the amount of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. Avgas produces approximately 19,000 BTUs of heat energy, while jet fuel produces slightly less. Rate of flame spread is the speed at which a flame travels across the surface of a body of fuel. Avgas has a rate of flame spread that is 30 times that of Jet A. This is an important factor to consider when evaluating the severity and potential fire hazard of a fuel spill. More importantly, it is a factor that can affect your ability to fight or control a fire. Simply put, an avgas fuel spill, once ignited, can turn into a raging inferno in an instant.
There is a marked difference in the rate of flame spread of Jet A and avgas. Avgas has a rate of flame spread that is approximately 30 times greater than Jet A. This is an important factor in evaluating the severity of the fire hazard of a fuel spill, and is also a factor which will affect your ability to control a fire.
The slower rate of flame spread of Jet A applies to jet fuel in its liquid form. Jet A and avgas essentially have identical rates of flame spread when they are atomized and released as a mist or have been heated to a temperature at or above their flash point.